Lunch and Learn seminar. Today's topic is going to be the Tolerance Analyst add-in found in SolidWorks Premium, and we're also going to look at the DimXpert, which is required before you can use the Tolerance Analyst add-in. The DimXpert is included with every version of SolidWorks, so even if you have SolidWorks Standard, you'll still have access to the DimXpert. You could think of the DimXpert, which can be accessed using this tab at the top of the Feature Manager, as the precursor to new functionality in SolidWorks that can be purchased as a separate add-on called SolidWorks Model-Based Definition, or MBD. Now, MBD is a tool used to present product and manufacturing information in a drawing list file format. What we can do is take a part that's been fully tolerant, such as this one, and we can export it as a 3D PDF or also as an e-drawing, which is what you saw during the intro of this Lunch and Learn. Before we can use the DimXpert, what we'll need to do is set up our values for what we want our tolerances to be, and the place that you're going to do that is in your system options. Look under the Document Properties tab when you're in a part, and you'll see a number of pages that are devoted entirely to the DimXpert. You can specify what type of tolerance you want to use, the tolerance values. Take some time to go through here page by page, set everything up the way you want, and then just keep in mind as well that because these are settings found in your Document Properties tab, you can save this as a template and all of your settings will be maintained. So make it a point to do that. And as a quick refresher, in order to save a part template, click Save As, specify the Save As type as a part template, and then give it some name that's going to make sense to you, of course, but maybe something like DimXpert Test or something to that effect. Once you have all of your tolerance settings established, to get the ball rolling and fully tolerance a model, you're going to first want to make sure you turn on your DimXpert toolbar. That's going to come in handy. So if you don't already have that turned on, bring up your toolbar list and select DimXpert, and that should pop up on the screen somewhere. And then the other thing you'll want to do is make sure you click that fourth tab over from the left. That's the DimXpert Manager tab. And then you'll have another row of buttons right below that, one of which is your Auto Dimension Scheme button. And if we click on that, this is what allows us to set up our datums and just some basic settings with regards to how we want these dimensions to look, such as plus and minus or geometric tolerancing. This really only works well for prismatic or turned parts, any kind of free-form shapes. This is not intended for. So kind of basic mechanical type parts is what the DimXpert is most well suited for. Let's pick our primary datum as this front face. For our secondary datum, we'll pick this bottom face, and I want to draw your attention to the fact that these two bottom faces here would be considered coplanar, and we're going to make that a compound face later, but for the time being I'm going to leave these as two separate faces. You'll see what I mean in a moment here, just if you want to bear with me for a second. And then let's pick for the tertiary datum this face. Leaving everything else set as is, I'm going to click on the green check and our dimensions come in. Now the reason why everything is turning green is because anything that is green is considered fully toleranced at this point. You can revert back to the original model colors by turning that button off. If we rotate this up, you'll see what I was talking about with regards to this face. It's not considered fully toleranced at this point. So I'm going to delete this this scheme, and we'll try it again. We can right-click the name of the part at the top of the DimXpert Manager, select Delete, and that'll allow us to delete all of our DimXpert features, as they're known as. Let's try this one more time. We'll create a new scheme. We'll accept all the same settings as we did before. I'll pick the same primary datum as I did before. For the secondary datum, when I select this face, I'm going to use this toolbar that typically appears, and we're going to create a compound plane. I can select this face, click the green check, then move on to my tertiary datum, which will be this face, and then we'll accept it. Once again, we get the same dimensions, but when I rotate this up, you can see that everything is green now. Well, this time, instead of plus or minus tolerancing, let's try geometric tolerancing. But before I do that, I'm going to go into the Customize menu, and under Commands, you do have a DimXpert section. And I think what I'd like to do is add the ability to easily delete my tolerance scheme if I want to, just by putting that command right up there on my command manager, and that way it makes it a lot easier to delete the existing scheme. And we'll start over, this time using geometric tolerancing. As I click the various faces to add my datums, it's kind of hard to see, but on the system feedback there's a small enter arrow, I guess you would call it, on the right mouse button. So be aware that you can right-click to accept that, and then just easily move on to the next list box, as you can see here. I'll pick this face, and we'll make that a compound face again, compound plane, with that face, and then right-click to accept it. Easily move to the next list box. That way you can quickly and easily pick all of the planes for your datums. And then we'll accept that. And there's an example of our geometric tolerancing. We can move those around and make everything look pretty. I won't spend too much time on that. I think you get the general idea. Before we go much further here, I think there's a couple of really fundamental aspects of the DimXpert that should be relayed, just so you get a better understanding of exactly how it works. One of those aspects is that it works off of any kind of imported geometry. It does not have to be a SolidWorks native part. So here's an example of imported geometry that we might want to work with. There's no features, as you can see. And when you're using the DimXpert, all it's really looking at is the topology. And because of that, all it can really see are the faces on the model. And the DimXpert, without your input, doesn't know that these faces here may be concentric, that all of them are part of the same circular cut. It also doesn't understand edges. You can't easily pick an edge. So I want to run through a couple of examples of special selection techniques which are very important when using the DimXpert. Here's an example. Let's say we'll put our datums in first and get that out of the way. So perhaps there's our A datum. I'll just run through and pick a couple. So as you can see, you can manually do that. You don't have to use the automatic dimensioning scheme to get those in. Matter of fact, you can manually add any kind of size or location dimensions as well. So as an example, let's try putting in a size dimension for one of these faces and see how that works out. When I go to add that dimension, one of our options is to tell it that this is going to be a compound cylindrical face. When I click that selection option, I can then go through and pick all of these cylindrical faces, thereby telling the DimXpert that the dimension that I'm adding pertains to all of those faces. Here's another example. Let's say that I wanted to dimension, let's say this hole here from this edge. Now, that seems like it should be a very straightforward and simple thing to be able to do. But keep in mind, once again, what I mentioned earlier, and that is the DimXpert only really sees faces, and anything beyond that, you have to tell it exactly where those edges are. So if I'm trying to add a location dimension and I pick this hole, one of the selection options is we can either make that a hole or a cylinder, and it might seem initially like those should be one and the same, and in this case really they are, but a cylinder could also be a boss, whereas a hole is strictly a cut. So we could probably go with either selection here and it wouldn't matter. I don't think it would make a darn bit of difference, but let's just leave it as the default setting of a hole. And then what I would like to do is try to pick this edge, but as you can see, it's just not letting me pick it. So I'll start out by picking this face, and here's where we could put an angular dimension in, but that's not really what we're looking for the sake of our example. So I'm going to tell it that I want to have it recognize an edge. So I'm going to create an intersection line. And the other plane, or planar face in this case, is going to be this face. And once I accept this, you can see that the dimension now understands where that edge is. So in this sense, the DimXpert is thinking a little bit differently than SolidWorks is thinking, in the sense that when you're trying to add a dimension, you have to think more of working with the faces rather than just picking edges to add reference dimensions and that sort of thing. I'll show you another example where if we want to add a size dimension to dimension the width of this rectangular cut, just picking the one face isn't necessarily good enough to get the width of that face. Instead, what I probably should do is pick the create width feature, which allows me to then select another face which infers that those two faces are parallel, which will play into my geometric tolerancing scheme later on. Another example of a location dimension. From here to the intersection of where the edge used to be before this fillet was added, I can pick one face, select intersection edge, pick the other face, accept it. Now I can dimension to that intersection edge. Now the real interesting thing here is that there is built-in error recognition. So let's wipe out our current scheme. We'll create another new one, and I'll pick the same datums as before. I think those are the same, not that it really makes too much difference. And we'll accept that. There's a lot going on here, obviously. It's difficult to see everything. So let me point you towards this dynamic annotation view option. When we turn that on, as we rotate this around, if the dimensions are parallel to our view, they show up. Otherwise they don't. Now, let me draw your attention to this one right here. Okay, so we've got a position geometric tolerance. I'm going to double click this to change it. I'm just going to change it to concentricity. And what we'll notice, if I rebuild this, is we've got what normally is associated with a dangling dimension color attached to the geometric tolerance. If we take a look in the DimXpert Manager, we can see the common error symbology that we're used to in SolidWorks. What's more, there's the what's wrong command that will pull up an error message that should hopefully point you in the right direction in resolving the issue. Let's take a look at another example that will be a little easier to fix. What you can see here is there's a couple of faces that, although they probably should be concentric, are obviously not. So that being the case, let's create a new scheme. My primary datum will be here. My secondary will be the outside cylindrical face. And then we'll let it do its thing. And everything looks good so far. the model's fully toleranced, but what I'm going to do is double click this geometric tolerance, and that brings up the properties panel, as you can see. And we're going to change this to concentricity. Now first, I'm going to remove the maximum material condition, and then we'll set this to concentricity, and we get an error message down here, as you can see already. But what I want to draw your attention to is if we rebuild this, you'll see the geometric tolerance has a color that's associated with it that's typically associated with dangling dimensions or geometric relations. And you can see the error symbol over here as well. You can right click and do it what's wrong, or you can mouse over it and read the balloon error message. So what do? Well, I don't want to reset this back to its original value. What I want to show you is how you can change the geometry, and the geometric tolerance error will be cleared because it's updating based on our underlying geometry. So we'll take this circle and drag it over to the origin and make everything concentric, rebuild that. And well, you can see already the color code has disappeared. There's no more errors in the DimXpert Manager. So it reevaluated the geometry, and it sees now that everything is looking good. So now that you have all of your geometric tolerances or your plus minus dimensions on the model, once everything looks good, your extension lines look nice, what are your options? What do you do with it at this point? Well, one thing you can do is, if you're working towards a paperless office, you can use the Save As command to save the part as an e-drawing. So that's one choice. Another choice is you could create a drawing just like you're used to. So we'll make a drawing from this part. And we'll go with our B-size template, I suppose. And then make sure that you check Import Annotations, and you'll see the option to import your DimXpert annotations. And any of the views that are preceded by the letter A means that those views are annotated. So we'll bring in our front view. We'll project up a top and a right side, and you can see that the dimensions come in. Now, one thing I've noticed is sometimes the datums have an extra line coming out of them, like you see here. It's a little glitch. Not sure what causes it. Graphics issue of some sort, possibly, but if you just drag the arrows, move them around a little bit, you can usually get that to go away, and should be a non-issue. Minor inconvenience, but that should do it. Well, let's move on to the next topic of discussion, which is TolAnalyst. Kind of hard to say. It is an add-in, and it can be turned on here. The TolAnalyst is only available in the premium version of SolidWorks. It is not available as a standalone, so you will have to purchase premium if you want access to this functionality. One of the first things you're going to have to do is open up each individual part on its own and run through tolerancing the part using the DimXpert as we just saw. So for example, if you want to make it quick and easy, like in this case, maybe we'll do plus and minus tolerancing, specify our datums, and we can say OK to that and have it pop in our dimensions for us. At a minimum, you're going to have to apply dimensions in the direction that you want to do the stacking tolerance analysis for. It's almost easier just to go ahead and let the DimXpert fully tolerance everything. In our sample assembly, you saw how I had already dimensioned one of the braces. I've already gone ahead and dimensioned the base plate and the end connectors as well, so all the components in this particular assembly do have dimensions applied to them now using the DimXpert. And again, that is a requirement. And the next step is we'll turn on our DimXpert toolbar again, and there is a command right there to start a new study. So once I click that, we need to establish a dimension where the study is going to be looking. So in other words, like the distance between these two braces, that's where, in our particular example, we want to concentrate on. So I apply a dimension there, and we can say next. And then you need to tell the software the order in which the parts are going to be assembled, and the order in which you pick them is significant. So let's start out with the base plate, and then let's say this piece gets mated in position, followed by this piece, and then this end plate, and then this brace, in that order. If we say next, now we need to specify the order that the mates are going to be applied. So you'll see these callouts. We'll try to see what the callouts are referring to as far as how the components are mated, and the faces are going to be making contact first, second, and third. Sometimes you only have to pick two. Let's say that this end plate is first going to be applied to the top of the base plate. So that's going to be the very first mate that gets added. Secondly, let's tell it that this end plate will be flush up against this front face of the base plate. So that will be the second mate that gets applied. That's all that it needed for that. So we can continue down through the list, anything that doesn't have a check on it. Let's go to the brace next. In this case, we'll tell it that the brace is going to be placed on top of the base plate first, then it's going to get pushed up against the end piece, and we've now got a green check there, and we can continue on. And in this fashion, you're basically telling the software how to put the assembly together. So here the end connector will be placed on the base plate. Then it'll move to the front face of the base plate, and we'll add the brace. Look for those green checks to get added. Okay, here it's going to be placed on the base plate and then pushed up against the end connector. Once you have all your green checks, you're ready to move on. So we'll say next, and we finally have what we're looking for. Our tolerance stacking analysis is done at this point. Now it's just a matter of interpreting the information. As far as interpreting the final results, you have your min-max values and RSS min-max values, root sum square values, listed here, as you can see. You can also double-click the contributing dimensions and pull up a dimension tolerance window, and changing these values will affect the final results. You can also export the results as an Excel spreadsheet. So that's about all I have for you. Thank you for watching this Dimension Tolerance Lunch and Learn. Hope you found it valuable, and we look forward to seeing you next time. Thanks again.
Don't forget to check us out on YouTube, Twitter, Facebook, and our blog for more great content by clicking on the links in the description below.